Okay, picking up where we left off with the ellipses yesterday, hoping that we can get through all these notes, which in all honesty, if I get to the back that last page and I only do one, it wouldn't be the end of the world. So, okay. All right, for example 2, we're still on the front page, so we're still talking about an ellipse that is centered at 0, 0. Example 2 asks us to find the equation of the ellipse, and it gives us the foci as 0, -3 and 0, 3, and it has a minor axis whose length is 4, and then it also asks us to sketch the ellipse. I know sometimes I do it just to try and make sure to draw things together for you. This one's actually asking me to sketch the ellipse, okay? So, with that in mind, we have to decide if this is a left or a right column ellipse, okay? A sketch, or starting the sketch, might actually help us a little bit and get started with this. And let's see. Okay, I put my sketch in the middle and then work around it. Okay. What's the one thing we can put on that graph right now? We have foci at 0, -3 and 0, 3. So where's 0, -3 and 0, 3?
And then hear me out, right? The minor axis is 4. Will that just put the other 2 points at 2 and -2 on the x-axis?
We'll talk about that in a moment, but yes. I'm not quite ready to go there, but I do agree. Now, okay, guys, what I want to talk about before I go any farther, which column do you think we should be in? Is this a left column ellipse or a right column ellipse?
Right. Yeah. Y-axis.
Are you guys with them? My foci are vertical, yes? My foci are vertical, which means my vertices are going to be vertical, which means this is a right column. So when I go to write my equation, I'm going to be filling in y squared over a squared plus x squared over b squared equals 1. Are you with me? Now, I can tell that by looking at the graph, that I can see my foci are vertical. I can also, if I go back to my chart for a moment, my foci were 0, 3 and 0, -3. Notice that matches up with the foci being in the y column, yes? In the y position. So that's the other thing I know. Okay, with that in mind, what else does my foci tell me?
Your C, right?
Okay. If my foci are 0 plus or minus C, then that tells me in this case that C is what?
3.
C is 3. Are you with me? Okay. Ask me to re-explain if I overlook something. Now, okay. So we know right now, since this is a right column, my ellipse is going to be tall, yes? It's going to be taller than it is wider. Okay. Minor axis has length 4. What's it say about minor axis up in your chart? On their chart, it says the semi-minor axis is B. And what did I essentially tell you then? The semi-minor axis is half of the axis. the whole minor axis is going to be 2b. So what I'm looking at here, since they tell me the minor axis has length 4, minor axis has a length of what according to the chart? 2b. So that means that what? 2b equals 4. And if 2b equals 4,
B equals 2.
we know that b is 2. So far, so good? So I know that C is 3. I know that B is 2. Now, if you look at the picture up by your chart, this is what Logan was talking about a moment ago, a minor axis having length of 4 or having a B value of 2. So the foci are on your major axis. Your minor axis is the one that goes the other way. So in this case, my minor axis is going left and right. And so if my minor axis has a length of 4, that means it goes out 2 each direction. So those right there are my B values, is what they are. Okay, my foci, what do we say the foci are? They are my C values. Your B values talk about how far out my ellipse goes the other way. Now, do I know enough to write my equation yet?
Gotta find A.
We have to know A. How do we find A?
Do the Pythagorean relation.
Anytime you know 2 out of 3 of your ABCs, right? We're going to go to that Pythagorean relation. So we're going to use A squared equals B squared plus C squared. So A squared equals 2 squared plus 3 squared. So A squared is 13, and that tells me that A is what?
Root of 13.
The square root of 13. Now, I am perfectly happy with the square root of 13. However, because I'm sketching a graph, can you also tell me what the square root of 13 is? Because I'm going to need a numerical value to sketch this.
.605. So 3.061.
Yeah, I'll just use 3.6 because in all honesty, the only reason I really want this decimal is because it's going to tell me where a point goes on the graph. Okay. Okay. So A is 3.6. Square root of 13 officially. Where is A on my sketch?
Above your focus.
Okay. A, remember, represents your vertices, which are outside of my foci. Okay. If I go back to here for right now, first of all, A are my vertices. And if you look at the picture here, here are my foci at C. Here are my vertices at A. So they're outside A. They are on your major axis. And so in this case, they're going to go up and down. Okay. So what that means is that my C value is at 3. Where's my A value going to be? 3.6. Okay. That also means the A value represents your vertice. So those are your vertices. Okay. Now, you're ready to finish your sketch. Do you know which dots to connect?
The A and the B's.
The A's and the B's, okay? Do the C's get connected? No, those are your foci. Remember, the foci are points inside the ellipse. So when I connect these, Wow, that's a pretty good ellipse for me. Sorry, I struggle to draw these things when I have to connect them through specific points. Okay, so there's my sketch of the ellipse. Now we still have to go back and do the other thing, right? We haven't written my equation yet, but do we have everything we need for the equation? Yeah, we do. Okay, and folks, by the way, the 0 here being in the foci, that's your clue that this is something centered at 0, 0. Okay, when one of your numbers in your vertices or your foci is 0, that's your clue that you are working with something centered at 0, 0. Okay, y squared over a squared. What was a? Square root of 13, quantity squared. I'll clean that up in a moment. Plus x squared over b squared. What was b? 2. So 2 squared equals 1. Okay. What do I really want to write here? Y squared over 13 plus x squared over 4 equals 1. Okay. Does it make sense that the bigger number is under y? Yes. The bigger number is always your a value, but it's under y because y is my major axis here. Okay? So a vertical ellipse, my y is always going to have the larger denominator. Okay? Did you follow at least? I'll be honest, the whole doing it on your own is a whole nother level, right? It's gonna be work. Okay. Next page, we get the next chart. Okay. So this page had the chart with everything centered at 0, 0. This page, now instead of being centered at 0, 0, we're centered at HK. Okay. So as you see in the pictures, my ellipses are shifted over and over one way or another and up or down. Now, while this chart may look intimidating, there's really a lot of the same thing. What changed in standard equation? The HK is thrown in. Okay? That's the only thing that changed. So it's the x minus h squared and y minus k squared. It's still over a squared and b squared. You're still in the left column going to have the x first over the larger denominator. In the second column, you're going to have the y first over the larger denominator. Okay? My focal axis now, instead of either being the x-axis or the y-axis, on the left it's going to be y equals k, on the right it's going to be x equals h. My foci and vertices. Do you still see the plus or minus c and plus or minus a? It's the same as the last chart we just looked at. The plus or minus c or plus or minus a. C and A are in the x's over here on the left. They're in the y's over here on the right. You just have the h's and k's thrown in there with them. And then the bottom half of this chart is identical. Semi-major axis, semi-minor axis are a and b. Pythagorean relation is still a squared equals b squared plus c squared. And if you want, what I like to teach, if the semi-minor axis has a length of a, what's the major axis have a length of? 2a. If the semi-minor axis has a length of b, then the minor axis has a length of 2b. Okay? Let's jump into 3. I mean, I could spend a ton of time going over this chart, but really, it's like the front. We just have to jump in. Okay, example 3. Find the standard form of the equation for the ellipse whose major axis has endpoints at 2, -1 and 8, -1, and whose minor axis has a length of 8. Do you have any thoughts on where to start?
So we can already make the ellipses.
Like as in draw a picture?
Yeah.
You can. And here's my thing, is I'm going to draw a picture and at least put those points on there so I can visually see what's going on. Some of you can visually, like, see it in your brain, and you don't need the visual on the paper. As a teacher, I need something to point at, so I want the visual on the paper. So I'm going to sketch a graph off on the left here. Let's see, I'm trying to think which ways I need to be able to go here. Okay, we already know, if I just put these dots on here, we have major axis has endpoints, so I know there's a dot at -2, -1, and there's a dot at 8, -1. Okay, thoughts on what I can do from here?
So your minor axis would be 4 up and 4 down from these.
Okay. You see what he's saying there? So one of the pieces of information that we are given, and I'm just going to kind of compose it all, minor axis has a length of 8. So in that, if we use this information, if the minor axis has a length of 8, well, in terms of variables, the minor axis is what according to my chart? Minor axis is 2b, excuse me, 2b. So if the minor axis has a length of 2b, if the minor axis has a length of 8, then we know that b is 4. Now, we were given major axis endpoints, yes? So those right there are major axis endpoints. Minor axis endpoints are going to go the other way. Now, a couple of things that we can figure out from there. If my major axis are going this way, are we talking left column or right column? Major axis is left and right, so that means my major axis is a horizontal axis. Which column is this? This is the left column. So this is, when I go to fill in my equation here in a little bit, x minus h squared over a squared plus y minus k squared over b squared equals 1.
Can't we just, for a, the distance between -2 and 8 is 10. Can't we just divide that by 2?
Okay. Are you guys seeing major axis? Basically, how long is my major axis here? If you count from -2 to +8, those numbers are how far apart? -2 to +8 is a distance of 10. So that means my major axis has a length of 10. Major axis, according to what I put on the chart, has a length of 2a. Are we tracking? So 2a equals 10, and thus a is 5. Which, we haven't talked about it. They gave us these major axis endpoints. I need to throw out that vocab word. What is the vocab word for major axis endpoints?
vertices.
right? The end of your major axis are your vertices, because then the foci are what's just inside, and vertices and foci are both on the major axis. Okay, so they like to do that. Did they give you the word vertices? No, but when we talk about major axis endpoints, I don't know if I exactly have enough room there, but we're going to make it work. Those are vertices they gave you. Okay, so just so you're aware, those are vertices at -2, -1, and 8, -1. Okay, I want to make that point that we have that vocab. Okay. Noelle?
So I have a question. So how do you get 10 if you a?
So 10 is just the distance from here to here.
Oh.
Okay? Now, what's the big piece of information I'm missing?
No, the K and H.
I need to know my center, don't I? I can't write an equation without knowing H and K. H and K represents the center. Where is the center? Well, it's somewhere in here, yes? Think logically. Where is the center?
In the middle.
In the middle? What's the middle of -2, -1, and 8, -1?
It'd be 3.
Okay. Could you just count in 5 either way? Because if it's 10 in length, 5 either way is going to put us right there. Okay. So that is my center. My center is at the point 3, -1. And if I know 3 and -1, those are what letters in my equation? H and K. Now, officially, could we draw the rest of this ellipse? I think it was Logan kind of mentioned it earlier. I wasn't ready to because I didn't have a center point, but my major axis goes this way. Minor axis has a length of 8, or in other words, it goes out 4 from either direction. So could I count and put the rest of that ellipse there? You can, and I'm going to. Technically, they didn't ask us to sketch this ellipse, but I think it was helpful in the teaching of it. Okay, so realize that, I guess I didn't put enough. That if you actually finish drawing this, you'd be going up 4 and down 4 to finish that ellipse. This is where my ellipse is going to get horrible. Okay. And again, if I'm trying to make the connections for you, realize this right here is a distance of A. This right here is a distance of B. Wow, a very lopsided B. Sorry, don't judge my ellipses. Okay. Have you written your equation?
Mm-hmm.
If you haven't written your equation, let's write our equation. X minus h. X minus 3, quantity squared over a squared over 525, or over 5 squared, plus y minus k, y minus -1 over b squared, so over 4 squared, equals 1. Folks, that equals 1 is important. If you don't put that equals 1, you're not writing an equation. Okay? I am going to clean it up if you didn't already. X minus 3 squared over 25 plus y plus 1 squared over 16 equals 1. Okay? Questions I need to answer in this one before we move on? Okay. Shall we try example 4 then? Okay. Example 4. Find the center, find the vertices, and the foci of this ellipse. Now, with that in mind, we probably need to start by picking out which column does this problem fall into. Eli?
Right.
And why would it fall into the right?
Because A is always bigger than B.
Okay. Here's the trick, right? I warned you about this. Technically, this is a plus sign. Does it matter which way I write this plus sign? Technically, no. Just because X comes first, does that make this a left column problem? No, it doesn't. It's a trick, okay? Don't fall for the trick. I could see the annoyed look on some of your faces. For the purpose of this problem, I'm going to flip this then. This is y minus 5 squared over 49 plus x plus 2 squared over 9 equals 1. That's what you really need to think about. And here's the deal. 49 with the y, this is the major axis. This is our major axis because the denominator is larger. So if you need to make yourself a note, please do so. And I made a note on the front page of notes yesterday. Maybe you need a note next to this chart today. Okay? Okay. With that information in mind, we need to gather some information from this equation. What information do you see?
You already know your center.
We already know the center. I agree. What do you guys think the center is?
-2, 5.
Look at the x. It's x plus 2. Use the opposite sign, so -2. Look at the y. It's y minus 5. Use the opposite sign, so it is plus 5. Okay, so I agree. I'm going to start gathering the information. So my center, which way did we say that? -2, 5. And keep in mind, it's -2, 5. What letters are those? They're what? H and K, yes? Are we going to need H and K here in a little bit?
Yeah.
Oh, most definitely.
So now you can find your vertices.
Okay. Let me write out, before we go too much farther, what is the formula for vertices that I'm going to be filling in so we can see what information we need?
H, comma, K plus minus K.
Okay, in order to do vertices, H, comma, K plus or minus A, because remember, we decided Y comes first. This is a right column problem. Feel free to write right column on your paper if you need to. And while we're here, what is my formula for foci also?
Same thing, but plus minus C instead of A.
Okay, H, comma, K plus or minus C. And you guys know where he's getting these from, right? These are coming from that chart on the top of this paper. Nothing fancy. I'm not making this up. You go straight to the chart and you read it. Now, we have H and K. In order to find vertices, I need A. In order to find foci, I need C. So let's go back and talk about our ABCs. What is A?
Seven.
A is 7. Okay, good. So right here, that 49, right, that is your A squared because it's bigger. So if A squared is 49, then yes, A is 7. Okay? What is B? Okay, so my smaller one, B squared is 9. So yes, B is 3. What is C?
Square root of 40.
And where'd that come from?
Pythagorean relation.
Okay, this is your Pythagorean relation. A squared equals B squared plus C squared. So 7 squared equals 3 squared plus C squared. 49 equals 9 plus C squared. So C squared is 40, which means C is the square root of 40. Okay.
Which is about 6.3.
6.3, did you say?
Yeah.
Okay. Okay. Let's go back into our vertices. H, which is -2, K, 5, plus or minus A, which is 7. Do you get to leave your vertices like that?
No.
No, why not? Can you do 5 plus 7 and 5 minus 7?
No.
Yes. Okay. So come up with your vertices. Tell me the vertices are what? -2, comma 12 and -2, comma -2. If you can do the math, do the math. Well, let me rephrase this. If the math is something that can be done, do it. Okay. Foci, H, comma, K, plus or minus, and I'm going to use the square root of 40. I want to be precise. So my foci are listed currently as -2, comma, 5 plus or minus the square root of 40. As it looks right now, can I actually do that math?
No.
No. 5 plus the square root of 40 is 5 plus the square root of 40. 5 minus the square root of 40 is 5 minus the square root of 40. I usually would suggest you just leave it like that. Okay? I would suggest you leave it like that. You could give decimal answers. For whatever reason, I have them in my notes also, but I would just leave it. Okay. I have a graph sketched. I'm not sure why, because I don't really feel like we needed a graph on this one. I have a feeling I was just showing a connection, but okay. We need to do this back page, yes? And on this back page, as I said, if I can get through one, I'm good. These are big problems. Okay. On this back page, you have one more little box. It's a little box. Okay. We talk about the vocabulary word eccentricity. Okay. The eccentricity of an ellipse, and it talks about it there. First of all, E is what we use for it. It is C over A. And I would just use that C over A. I'll change the screen here in a moment. I have some people still copying, I think. So I would just use the c over a. That square root of a squared minus b squared, that's just how you find c, okay? But we know about a, b, and c, so that's not, we already know how to find a, b, c, so you're good there. Couple of key points down below. Eccentricity is always a number between 0 and 1, okay? And it describes how elongated the ellipse is. Is it very long and skinny, or is it closer to being a circle? That's what eccentricity is.
So if you're saying on homework we don't get an answer for 0, between 0 and 1 for these problems, we get it wrong.
Correct. Okay. The larger E is, the more elongated the ellipse is. When E is 0, the ellipse is a circle. Okay. Okay. Let's look at this problem. Okay, now, right there, folks, that's what I was talking about. Just use E equals C over A because you know how to find C, you know how to find A. Just worry about that. Now, these examples, though, are a little tedious. Here's the catch. What kind of equation do they give us? It's not in standard form, is it? Okay, so that's the catch, is we've got to get this in standard form first. So show that this is an ellipse. That's going to be, we're going to get it in standard form, and then find vertices, foci, and eccentricity. Okay, I've got to speed up my process, or we're not going to get done. We want our x's together, then our y's together, and any plane numbers move to the right. So I'm going to write this out as x squared minus 2x. I'm going to go ahead and leave a gap. Well, no, I don't have to leave a gap quite yet. Plus, and I'm going to have my y's, 6y squared plus 12y. And then, what's moving to the other side? We're going to add the 23 to the other side. Okay, so what I've done is I'm grouping x's, then y's, then just constants. Now, here's the deal, guys. Think about the top of those fractions in this standard form. It's x plus or minus a number of quantity squared. It's y plus or minus a number of quantity squared. Folks, we're going to have to complete the square to do this. Okay? Now, in order to complete the square, I am going to leave gaps this time. X squared minus 2x, leave a gap. Plus, now there's a catch here. In order to complete the square, what kind of x squared term does it have to be? It has to be a 1x squared. Does that sound familiar? You have to have that coefficient. In order to complete the square, we talk about it has to be x squared plus bx. This is 1x squared. Is this y squared 1y squared? No. But what can I factor out of my y terms? A 6. So I'm just right here going to factor out the 6. And then what do we have remaining? Y squared plus 2y when I factor the 6 out of the y terms. I'm going to leave a gap into my parentheses and put my equals 23 on the right. You with me? Okay, x's. How do I complete the square on the x's? What's b? b is negative 2. So what are we doing? b over 2, quantity squared. I did this the other day, right? So negative 2 divided by 2, quantity squared. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. What do I do with that 1? I add it in the gap after the x's. If I add a 1 on the left side of the equation, you add a 1 on the right side of the equation. Repeat the process for the b's, or the y's, sorry. On y, what is my b value here? b is 2. What do we do? b over 2 squared. So 2 divided by 2, quantity squared. Coincidence, again, I'm getting what? 1. We're going to add 1 on the left. I'm adding it in the gap. I'm adding it in the parentheses.
And so,
If I add 1 on the left, we have to add 1 on the right. But is this really a 1 since I put it in these parentheses? What's this 1 being done? It's being multiplied by 6. So over here, I'm really adding, I'm writing it as 1 times 6. But I agree, Eli, it's a 6. Okay. Now, continuing. On the left, after you complete the square, you factor.
x minus 1 squared.
Square root of x squared is x. Square root of 1 is 1. This is a minus sign in the middle, so x minus 1 squared. Plus, the 6 stays 6. And then, square root of y squared is y. Square root of 1 is 1. This time, though, it's a plus. So x minus 1 squared plus 6 times y plus 1 squared equals 30. Now, first example yesterday, I think it was, how do we make this standard form? That 30 needs to be a 1. How do I make that 30 a 1?
Divided by 30.
You're going to divide by 30. So we're going to divide everybody by 30, which means I'm dividing my x minus 1 squared by 30, my 6 times y by 30, and my 30 by 30. Okay. X minus 1 quantity squared over 30 is just that. Plus, what do you know about 6 over 30? Reduces to be 1/5. So this is y plus 1 squared over 5 equals 1. Now, right there, we showed that it's an ellipse because what did we just do? It took a lot of work, but we got it in standard form. Is this a left column or right column problem? The bigger number is under x,
So it's a little.
so it's left column. This is x minus h squared over a squared plus y minus k squared over b squared equals 1. Now, I'm out of time, as I was getting ready to say. Based on everything we've done, we have to find vertices, foci, and eccentricity. That means you have to know HK and ABC. I would like to think maybe you can find HK and ABC. Maybe we'll talk about it at the beginning of class tomorrow also. Here's the deal. I want you to do the homework. Okay? This goes with probably 46 and 48 is where you're going to get a little stuff. Try 46 and 48, okay? Try them. Try and do at least this part. And then look at your formula. You have to know HK, ABC. You guys can find those. You can't. But I'll help you tomorrow to get stuff. So page 582, 2 through 6 evens, 7 through 10, 22 through 40 evens, 46 and 48. Folks, there's going to be questions. Okay? My plan tomorrow is probably to maybe finish this example if we need to, and do questions. Okay, I don't know that we'll get to start hyperbolas tomorrow.
Oh no.